Hi everyone. Today we are going to be considering a topic, equations of uniformly accelerated motion. And what we are going to be doing in this video basically is to show us how to derive equations of uniformly accelerated motion. At least we are going to derive 4 of these equations and how to apply them in solving some of the past problem in our senior secondary school certificate examination, that is our WAEC, NECO and even UTME. Okay, to start with, we are going to recall the definition for total displacement that we discussed in one of our previous videos. In that video, we mentioned that total displacement equals average velocity multiplied by total time. That is the product of average velocity and time. That is what our total displacement is. And if we are to represent this mathematically, remember the symbol for displacement is S, while the symbol for average velocity, when we say average velocity, it means we are dealing with more than one velocity, and it is appropriate to use average velocity in as much that when we're in a journey or when the system is moving, it is a bit difficult to have actual velocity at every point in time, except we have just instantaneous velocity. So to describe the entire velocity of the journey, we use the word average velocity, which is referred to the sum of initial velocity and the final velocity divided by 2. That is what this average velocity represents. Okay, and our time is small letter t. Now if we put that into equation, if S represents our displacement and for our average velocity we have u as initial and v as final divided by 2, that represents our average velocity. And this, if we multiply this with our time, so in our equation we can see that displacement S is given as u plus v over 2, everything multiplied by t. And this statement of the definition of total displacement represents the first equation of uniformly accelerated motion. That is, whenever a equation is talking about a body moving with uniform acceleration, we can use this equation to solve the problem. Now let's consider the second one from the definition of acceleration as well. As we all know, we know that acceleration is the rate of change in velocity, or we can put it in another way by saying changes in velocity with respect to time. And that is what we have on the screen here. And we can as well represent this one with mathematical equation. A is the symbol for acceleration, and when we say change in velocity, it means we have more than one velocity. Like we consider in the case of average velocity, change in velocity simply means a final velocity minus initial velocity, and that is what we have here. Okay, and whenever we say rate, it means we are dividing that quantity by time. So that is what we have on the screen here, and from there we have this equation, and making v the subject of the formula, we have this, and this represents the second equation of uniformly accelerated motion. This is the second equation of a uniformly accelerated motion. Now from these two equation, that is the one that we derive from the definition of total displacement and the one derived from the definition of acceleration, we can derive 2 more equations from these 2 equations. Okay, let's quickly consider that. All right, let's move on to the next line here. Now in the next line here is we have on the screen from equation 1, which is this. We have to substitute u plus at for v. That is in equation 1 we have v in equation 1, and we are able to derive v to be equal to u plus 80. So we can replace v in equation 1 by u plus 80 that we derive in equation 2, and that is what we are going to do, and that makes our equation 1 to become this, because v has been replaced with u plus at, and with this v has been replaced with u plus at, and with this we can perform mathematical operation. U plus u will give us 2u here, and we have our 80 over 2 according to what we have here. Okay, now opening the bracket with t, and we cross multiply, so these two will go and meet this as that is what we have here, and opening these brackets here with t, we have a 2ut plus 80 square. Okay, now from this end we can divide both sides by 2. That mathematical operation will lead us to s equal to ut plus 80 square over 2 if we divide both sides of this equation by 2, and this gives us the third equation of uniformly accelerated motion. Third equation of uniformly accelerated motion. Okay, now let's look for the fourth one. Let's try and look for the fourth one here. Okay, from what we can see on the screen here, let me adjust it very well. From what we can see on the screen here, from this equation as well, we can make t the subject of the formula, and that is what we did here. That's what makes us to have t equal to v minus u over a. And with that, we can as well substitute this one, this particular equation, t equal to v minus u over a, for t in equation 1. Let's quickly check equation 1 again. Okay, now we can just go back to equation 1. You can see the position of t in equation 1, so we can substitute for this. We can use v minus u over t to replace this here. Okay, now to do that, let's see how that is done to create our fourth equation. Okay, from the statement that we have here, we have to substitute this equation for t in equation 1. Remember, our equation 1 is s equal to u plus v over 2, everything into bracket t. So if this t is replaced with this particular equation, definitely what we are going to have is what is here on the screen right now. And if you play around mathematics here as well, we can open the brackets in the numerator and do a cross multiplication of this with this, that is 2a multiplied by s, and that will give us 2as. And opening the bracket at the top here make us to have something like this. You can practice this. This is what you've done in the past in mathematics. And as you can see from this one, this will take this out, or probably you can as well use a difference of 2 square. Definitely you are going to arrive at 2as equal to v square minus u square. Yes, that is what you have. And making v the subject of the formula, we are going to have v square equal to u square plus 2as. That is what we are going to have here. So that is what represents the equation of the fourth equation of uniformly accelerated motion. Okay, let's look at how we can use these equations in solving problems. Let's look at how we can use these equations in solving problems. In our example 1 here, in our example 1, we have an object start from rest and moves with uniform acceleration of 0.5 meter per second square. We have to calculate the distance covered in 10 seconds. Okay, from this we can see our given parameters are acceleration, which is 0.5 meter per second. We have the time 10 seconds, and we have to calculate the distance covered in these 10 seconds. But remember, this journey starts from rest, therefore our initial velocity will be 0 meter per second. And considering these four parameters, U, S, T, A, we can find all these four parameters in our third equation of uniformly accelerated motion. That is why we chose that equation. So substituting all these parameters into the equation, we are going to have what we have next on the next line here. Okay, remember our u equal to 0, so that makes this part of the equation to be equal to 0, and also our a equal to 0.5 and our t equal to 10. So 10 squared will give us 100. Pressing this on your calculator, we are going to arrive at 25 meter as the distance covered in 10 seconds. Okay. In example 2, we have a car traveling at 50 meters per second, accelerating uniformly at the rate of 3 meters per second square. We have to calculate the velocity after 60 seconds. Now, if you look at this question very well, there's no instance of maybe the journey starts from rest or end at rest. So the velocity mentioned here will be our initial velocity, while we have acceleration of 3 meters per second square, and we have to calculate our final velocity, that is, or let me call this instantaneous velocity after 60 seconds. Okay, and with that, looking at these four parameters that we have in this equation, that is, we are looking for V, we have T, we have A and U. The equation that suits this question is V equal to U plus AT, and that is why we chose this. And substituting all these parameters into the equation, we have this, and that will lead us to this. So our final velocity, or probably we can call this instantaneous velocity since the journey is still on, and that will be equals to 230 meters per second. Okay, now let's consider our third example. In our third example, we have a car traveling with the speed of 30 meters per second, and this car begins to decelerate uniformly and come to rest in 5 seconds. Now we have to find the distance that the car travels during the braking. Now from what we've discussed so far, we know that when a journey comes to rest, it means our final velocity will be 0, because the vehicle, the body will stop moving. And according to the question, we have initial velocity given as 30 meters per second in the question, and we have a time t equal to 5 seconds. We have to calculate distance traveled in these 5 seconds. Considering these four parameters that we have in this question, the equation that suits this question is S equal to U plus V over 2, everything multiplied by 2. Okay, now using this equation, substituting our values into this equation, we have this, that is 30 represent our U, Y 0 represent our V, and our T equal to 5 seconds. And using a calculator on this, we're able to arrive at 75 meters as the final answer there. Okay, let's consider the last example in this video. Okay, the last example says a car accelerates uniformly from rest at 4 meters per second square. That is, we have acceleration of 4 meters per second square. So they now ask us, how far will it travel in 50 complete seconds? This one is a bit different from all the questions we've been treating. Here we have how far will it travel in the 50 complete seconds. That is in the 50 seconds of the journey, not after 5 seconds, in the 50 seconds of the journey, which is just the duration, the distance between the 4th and the 5th seconds. That is duration between when the time t equal to 4 seconds and when the time t equal to 5 seconds. That is what they want us to consider. So in writing out our given parameter, the journey starts from rest, so we have our u to be equal to 0, and we have acceleration of 4 meters per second square, and our time this time around will be t5 minus t4, and we are looking for our distance. Okay, now substituting this value into this equation, we can see that from the question we have these four parameters S, T, A, and U. Okay, Now, substituting whatever we have in this question into the equation, we have this one here, because our time is the time interval between t equal to 5 seconds and t equal to 4 seconds. So that's why we have our equation rewritten in this form. And with this, we can substitute the value of our time into this equation. We have this using a calculator. The distance traveled in the 5th second of the journey will be equal to 18 meters. Or we can as well calculate the distance traveled using this equation. The distance traveled when t equal to 4 seconds separate, and calculate the distance traveled when t equal to 5 seconds. So if this one is S4 and this one is our S5, so the distance traveled in 50 seconds will be S5 minus S4. That's another way of solving this problem. So any of the way that is easier for you is also good. You still arrive at the same answer. Okay, with this we come to the end of this topic. But just before we go, please, I would like to introduce to us again one of the best physics practical book that you can see around this time around. The name of book is Reform Physics Practical Book. And what makes this book to be among the best is the fact that this book is designed to serve both students, both our school candidates, that is students that are preparing for WAEC and NECO in our schools, and also private candidate, that is the student that are preparing to write GC and NECO GC. That is, the book is having practical exercises for the school candidates, and also alternative to practical exercises for GC and NECO GC candidates. And also, in addition to that, we have practice exercises for students preparing for Cambridge IGCSE as well. And in this book, we have a chapter talking about how to handle practical in real time, how to present your observation table following every rules and regulations, how to avoid errors, and also how to plot your graph, how to determine your intercept, how to write your precaution, acceptable precautions. All of them are discussed in this book. And the name of the book again is Reform Physics Practical Book. And please, if you care to have one or have a copy of this book, you can contact any of the numbers shown on the screen, or you can use the email address. Or if you want the soft copy of the book, you can as well click on the link here. This link will lead you straight to where the book is on Amazon. You can as well buy the soft copy of the book on Amazon. For the candidate preparing for GC and NECO GC, this book is very, very good for you. We have so many practical exercises on alternative to practical. Also, in addition to that, we have some other services that we offer on this platform. Reform Physics Tutor virtual teaching platform is designed to handle a tutorial in both physics and mathematics for the examinations that you can see on your screen. We handle online tutorial for WAEC, NECO, UTME, Cambridge IGCSE, and some others. In case you are interested in any of these services, please feel free to contact this number on the screen or WhatsApp. And before I go, please kindly remember to subscribe to our channel so that you have access to our subsequent videos, and also click on notification button. And if this video has added one or two things to your knowledge, please kindly give us a thumbs up, and also drop your comment in the comment section. And in case you have any question, please feel free to drop your question at the comment section, and the question will be attended to. Please, before I go, to make sure that we keep this channel alive, please kindly subscribe to the channel so that you have access to a subsequent video. Thanks for watching.